Section 2.7 and 2.8 go hand in hand, and we're talking about fitting a model to the data. So basically what we're going to do is take a look at a story problem, a real world example, and say which part of our variation equations best fits this data. So if you think about it, we have four main equations. That's y equals k times x, y equals kx squared, y equals k divided by x, and y equals k divided by x squared. You should remember that these first two are examples of direct, which means both variables are going up, and the second two are inverse, so one goes up and one goes down. So we're going to use the idea of section 3 a little bit to help us decipher, but we should be able to narrow it down to either direct or inverse, just thinking about what the data is telling us. So example A is talking about Perry Mentor, and he was investigating a relationship between volume of pressure of gas in a lab. When she holds the temperature of the gas constant, she varied the pressure and measured the volume to give the following data. So the first thing you want to do is go ahead and graph that so you can see what's going on. So go ahead, pause this and graph it. Okay, so hopefully you got a graph that looks like mine. So as you can see, we've got pressure on the x-axis and volume on the y, and you're saying, okay, as this pressure is increasing down here, the volume is decreasing. So already you should go, okay, is this direct or is this inverse? Well, that makes this an inverse relationship because one is going up and one is going down. Okay, so the model type, you've got two options. You've got y equals k over x or y equals k over x squared because I knew it was inverse. So now I'm going to try and actually figure out which one it is by picking 2 points. And I usually try and pick points that actually kind of go together. So like 20 and 40. Okay, that's kind of a nice relationship because that means 20 times 2 gets me to 40. Okay, so try and pick numbers that are not right next to each other. So I cannot pick 30 here, okay, because it was right next to each other. So try and find something further away. 60 would have also worked, and so would have 80, okay? But try and find something that works nice. So if the top is multiplied by 2, now I say to myself, okay, how do I get from 83 to 42? Well, I divide it by 2-ish, okay? It's going to be close. It may not be exact, okay, but it's definitely not 4 because my other option would be 2 squared, which is 4. So I know that I'm just dividing by x, so that means I'm going to pick this equation, the divide by x, because these numbers are the same. If I multiply by 2 and divide by 2, I am just going to have the same power to both, kind of like we talked about yesterday, because then this is just a x to the first, okay? If this was a 2 and a 4, then I would have picked this guy because 2 squared is 4. Okay, so now we actually have to find the k value. So I'm going to go ahead and I'm going to pick one of my ordered pairs. So I'll pick this guy. So I can plug 42 in for my y. I don't know x, but I don't know k, but I know my x is 40. So to solve for k, I can multiply each side by 40 here. So I know that k is going to be 1680. So now when I go to write the equation, my equation would be y equals 1680 over x. Okay, so this is kind of the end goal. 1 through 4 are kind of the steps to get there, okay, but 5 is your end goal, is to write the equation. And then I can answer the question, use the model to predict the volume if it has a pressure of 45. So all I would have to do is plug in 45 for x into my equation. So I'd have 1680 over 45, which would give me an answer of about a 37 1/3 cubic feet. Okay, so we're looking at the relationship. Again, maybe kind of weird, so we'll go over lots of examples so you can kind of see the difference. So example B just gives you a graph. It doesn't give you any data. Well, by looking at this graph, you should know that this is an inverse graph. So my two options are y equals k over x or y equals k over x squared. Well, since I can't pick any points, okay, you can pick either one of these. Okay, it's a kind of a 50-50. I'm not going to be too picky here because you don't have exact data points. But I am going to be picky about the fact that you put it in terms of S and R. Okay, well, R is on the x-axis and S is on the y. So your real answer should say something like S equals K over R or S equals K over R squared. Okay, so you do have to go ahead and put it in terms of the variables that they give you. Either one of those is fine. So let's try example C. Mark was trying to determine how the pressure exerted on the floor by the heel of a shoe depends on the width of the heel and the weight of the person wearing the shoe. So now in this example, we're taking more than one thing into account. So first we're going to take a look at the weight and the pressure, and then we'll take a look at the heel width and the pressure. So again, we're going to do it one step at a time, kind of following those same steps. Well, as I look at my table, I notice my weight is increasing and so is my pressure. So now they're both going up. Okay, so these are going to be a direct relationship. So I'm either going to have y equals kx or y equals kx squared, okay, because they're both going up. So again, I'm going to try and find something that kind of looks like it's going to multiply nicely. So if I pick 62 and 128, that means I'm multiplying by 2. And then 11.2 to 23.06 is about 2. So again, I have timesing by 2 on both the x and the y, which means there's no exponent involved, which means I'm going to choose my y equals kx because that's an exponent of a 1. Again, I need to put this in terms of my weight and my pressure. So always remember the top is x and the bottom is y when you're given a data table. So I can say that P equals KW for this first part. Again, the way you know if it's not going to be just x, if this top number was a 2 and the bottom was a 4, then I would use the x squared because 2 squared is 4. Okay, but so far we've seen just direct relationships where it was being multiplied by the same factor. So that deals with the weight and the pressure. The second part deals with the heel width and the pressure. Okay, so now if I look at my heel width, you're going to notice those numbers are going up, but you're going to notice the heel pressure numbers are going down. So I've got one going up, one going down, so this is going to be an inverse relationship, which means my options are y equals k over x or y equals k over x squared. So again, let's take 2 points and find the relationship. So maybe I would want to use 1.25 and 2.5 all the way at the end because I'm multiplying that by 2. So if I look over here, okay, well now if you're having a hard time, obviously if we're going down, now we're dividing by something. So I would say is 127 divided by 2 going to be 25.4? Not quite. It's more like dividing by 4. Okay, so now I have 2 and 4, which are different numbers, and 2 squared is 4. So this time I pick y equals k over x squared. So maybe seeing a different example is helping you to realize how you choose. Okay, so the numbers are different, and it is exactly that number squared. So I could have had like a 3 and a 9, a 4 and a 16, a 5 and a 25. Anything squared would give me the squared equation. Okay, so now again, I need to put it in terms of the variables being used. So now I can say P equals K over H squared. Okay, now what we have to do is put that all together into one because both of these things, the weight and the heel width, are affecting the pressure. So what I'm going to do is kind of just mash them into one. So I'm going to say together P equals KW because the first one was direct, and then over H squared because they're both having an effect. Okay, I can kind of just mash them into one. Okay, so example D is kind of the same idea, only dealing with the visual way. Okay, so now I've got this first graph here. Should realize they're both going up, so this is a direct relationship. Now, in a direct relationship, you should be able to tell the difference between a line and a parabola. This is definitely a line, so this is definitely a y equals kx. To put that in terms of n and m, I'm just going to kind of label my x's x and m, x and y, so that my real one will say m equals kn. Now the second one, okay, is also direct because they're both going up here, but now this is definitely the part of a parabola, so that's going to be y equals kx squared. Again, label that x and y, so that one is m equals kr squared. Now together, those two mashed together would be m equals knr squared. You do not need to do anything with like the fact that there's two k's because k is just a number. So if I had a number here and a number here, it's still a number there. Okay, so m equals knr squared. Again, this might be kind of a tricky thing. So go ahead, stop and think, see if you is something that you can do and something that you still have questions about. Please write something down and come to class with questions tomorrow.